Okay, we are in section 8.1. 8.1 is systems of linear equations. So 8.1, this is page 766 in your book. Systems of linear equations in two variables. Systems of linear equations in two variables. Okay? Systems of linear equations in two variables. Okay? We're going to learn what they are, we're going to learn how to solve them, etc. Okay? So, real quick, an example of something like that might be 2x plus 1, or 2x plus y, I'm sorry, equals 7, negative 3x minus 2y equals negative 2. Those two equations with those two unknowns, x and y, comprise a system of two equations with two unknowns. This is what we're going to learn how to solve. Now, systems of linear equations. Linear equation. So in actuality, this is a line and that's a line, right? So it's going to be two straight lines in the plane, okay? Those two things are going to wind up to be two straight lines in the plane. Well, a solution to a system, just like the one we got right here, of equations, is an ordered pair. An ordered pair, x comma y, that solves both, and that's the key word, both equations. So if I'm going to have some x comma y at some point, that point has to live on both lines. So in other words, when I find this x comma y that's supposed to be a system for the whole system, then that x comma y will solve the first line and it will be a point on the second line. So with that in mind, example 1. Okay? With that in mind, example 1. So example 1, we're just going to make sure we understand when a point is a solution to a system or not. So determine if the ordered pair is a solution to the system. Determine if the ordered pair is a solution to the system. So they give me a system, 6x plus y equals negative 2. Second thing in the system, second equation is 4x minus 3y equals 17. So there's my system of two equations, two unknowns. And I want to know, are the following ordered pairs solutions to the system? So the first ordered pair they give me is 1/2 negative 5. 1/2 negative 5. So I check the first equation. I've got 6x plus y equals negative 2. Where I had an x, I'm going to put a 1/2. Where I had a y, I'm going to put a negative 5. So I'm just going to say minus 5. And the question is that equal to 2? 6 times 1/2 is 3. 3 minus 5, and it's a negative 2, I'm sorry. Is that equal to negative 2? 3 minus 5 is exactly negative 2, so yes, they're equal. So this thing is a solution to that one. Let's look at the second equation. 4x minus 3y equals 17. Where I had an x, I'm going to put a 1/2. Minus 3 times. Where I had a y, I'm going to put a negative 5. Okay? 4 times 1/2 is 2. 2 minus 3 times negative 5. Negative 3 times negative 5 is plus 15. That's 17. I had 17 on the other side. So is this a solution to the system? Yes. This point solves the system because that point is a solution for both lines. That point lives on both lines. Let's look at B. B says, they give me another ordered pair, 0, negative 2. 0, negative 2. So again, take the first line, 6x plus y equals negative 2. Where I had an x, I'm going to put a 0. Where I had a y, I'm going to put a negative 2. And the question is that equal to negative 2? Well, that's 0, so yes, negative 2 equals negative 2, that's fine. What about the second line? 4x minus 3y equals 17. Where I have an x, I'm going to put a 0. minus 3 times, where I have a y, I'm gonna put a negative 2. Well, that's 0, 4 times 0 is 0. Negative 3 times negative 2 is positive 6, but 6 is not the same as 17. So no, that point is not a solution to the system. So this first point, 1/2 comma negative 5, is a solution to the system because it solves, or it is a point on both lines. The second order pair is not a solution to the system because it only lies on one of the two lines. That point is on the first line, but it is not on the second line. So to be a solution, that point has to live on both lines. All right, so let's think about this. We know a lot about straight lines. We've dealt with them this semester. So we have two lines in the plane. Two lines in the plane. And what we want to do is we want to look at the possibilities. We want to look at the possibilities. So let's just think about it practically, logically. So I got an x and a y axis. So suppose one line is like this, there's line L1, another line is like this, there's line L2. Well, those two lines cross right here at some x comma y. Anytime two lines cross at a point x comma y, that means that there is one solution to the system. Okay? There is one, and that's the point where they cross. So I could figure out the solution to a system of lines, two lines with two unknowns, by graphing them. Now that's not the most efficient way, but I could figure out the solution to a set of linear equations by graphing those two lines. Wherever they cross, that will be the solution, okay? So if they cross in one place, that's the solution to the system. This is called a consistent system. You can read this in your book, you better be reading. This is called a consistent system, okay? This is all in your book. One unique solution, excuse me, consistent. Well, the second possibility for two lines in the plane, x and y, so one line might be like this, L1, the other line might be like this, L2. And L1 might be parallel to line L2. Well, if they're parallel lines, they stay the same distance apart forever. They never cross, okay? So there is no solution to this system. This is called an inconsistent system. So that's the second possibility for two lines in the plane. Two lines can cross at one point, one unique solution, that's a consistent system. Two lines could be parallel to each other and never cross, that's an inconsistent system. There will be no solution to an inconsistent system. The third possibility is one that might not occur to you, but the third possibility is sometimes, so for instance, let's look at this line. I'm just going to make up a line real fast. So consider 2x minus 3y equals 4. Let's solve for y. We're going to solve this line for y. Negative 3y equals negative 2x plus 4. Divide by negative 3. So y would be 2/3 x minus 4/3. So if I just wrote down a system of two equations and I said 2, and you hadn't seen this, and I wrote the other line as 2/3 x minus 4/3, if I said that was some system of two lines with two equations, if you hadn't seen me do that, you'd think that these were two distinct different lines. But this line and this line are the exact same line. I just wrote it in a different form. So the third possibility is line L1 is actually the same as line L2. They're the same line, so one lies on top of the other, but the equations can look very different depending on how it's written. This line and this line are the same line, but you might not have known that because they're written in different forms. So the other possibility is they're the same line. If they're the same line, there are an infinite number of solutions. Infinite number of solutions. Because every point that's on the first line is on the second line. So any point that's on one line is on the other. So there's an infinite number of solutions. This is called a dependent system. A dependent system. So these are the three possibilities we're going to have in terms of solutions. Okay? If two lines cross at a single point, it's going to be one unique solution. That is a consistent system. If the two lines are parallel to each other, that's considered to be a inconsistent system. There's no solution to that. The two lines could be the same thing, and hence you will have an infinite number of solutions. Any point that's on the line is a solution to the system because they're the same line, okay? So those are our three possibilities. This thing is in a chart on page 767. There's a chart on page 767 that spells this out a little better than I do, okay? But that should make sense because that's how lines behave. They'll either cross one in one point or they'll never cross. Parallel lines are the only lines that never cross. Or again, it could be the same line and you may not have known it is all. It could have been the same line, but we just didn't know it. So now how do we solve? How do we solve? We solve systems of equations. Okay, how do we solve systems of equations? So method one is called substitution. And I'm not going to write it all down, I'm going to do one. They talk about substitution on page 768. So read that description. I'm going to do one. It's pretty obvious how substitution works. Okay, but I'm just going to do an example and I think it'll be pretty obvious. So example 2. Solve the system. Solve the system. Negative 5x minus 4y. They say equals 2. And the second line in the system is 4x plus y equals 5. So there's my system. There's my system. The two lines are negative 5x minus 4y equals 2 and 4x plus y equals 5. I want to solve that system. I'm going to use substitution. Substitution literally means what it says. So I'm going to take either one of the two equations, and I'm going to solve for one of the variables. So I'm going to take 4x plus y equals 5, and I'm going to solve for y. Because it's the easiest thing to solve for, that's all. Always solve for the easiest variable in either equations. It never matters. So since the y there's nothing in front of y, that's the easiest one to solve for. So I'm going to solve this equation for y. I'm going to subtract 4x from both sides. Y equals negative 4x plus 5. So I've solved for y. Okay? Now, and hence the name, substitute. So now substitute this value into the other equation. That's why they call it the substitution method. You're going to solve one of the two equations for one of the variables, doesn't matter which one, and then you'll substitute that value into the other equation. So now that I know that y is the same thing as negative 4x plus 5, I'm going to take this other equation, negative 5x minus 4y equals 2, and where I had y, I'm going to replace it. Y supposedly is the same thing as negative 4x plus 5 equals 2. So that's the substitution part. We solved for y, okay? And we could have solved for either variable in either equation. It never matters. But y is the easiest thing to solve for. If you solve for any of the other things, you're going to have fractions, which the problem still works fine, but students don't typically like fractions. So we solved for y. Then we took the other equation and we replaced y with the value we got from when we solved that first equation for y. And now we've got an equation that has only one variable, so now we can solve this thing for x. So let's work on it. Negative 5x. Negative 4 times negative, because this is multiplication. Negative 4 times negative 4x is minus 16x. Negative 4 times a positive 5 is minus 20 equals 2. These are like terms. I get negative 21x when I combine them, right? Add 20 to both sides, then divide by negative 21. X is negative 2. X is negative 2. And they got x equals 2. Oh, I see it. A negative times a negative is a positive 16x. Negative 4 times negative 4x is a positive 16x. Negative 5x plus 16x, that's 11x. Okay, sorry about that. So we're here, right? We're here. And then I add 20 to both sides. Now I divide by 11. X is positive 2. Sorry, x is positive 2. Now that I know x, now I can go to either one of these two equations and replace the x with its known value, and then I'll have y. So I'm going to take this one, 4x plus y equals 5, x is 2. So 4 times 2 plus y equals 5. Okay? 4 times 2 is 8, plus y equals 5. Subtract 8 from both sides, y is negative 3. Okay? Y is negative 3. So our solution is x comma y. X is 2, y is negative 3. That's the solution to the system. A solution to a system will always be an ordered pair. It'll have x and a y coordinate. Now, if you wanted to, you could check that solution. You'd have to put it in both equations and make sure it satisfies both equations, though. You can't put it in just one. If you put it in both equations, it will work. So there's my solution. This is a substitution method. And we saw why they call it the substitution method. Solve either equation for any one variable you want. Take that value, put it in the other equation. Then you'll have an equation with one unknown. Solve and you'll get one of the two unknowns. Once you figure out what x or y is, then you'll go back to your original equations and replace that value in either one of the equations and find the other unknown. That's why they call this the substitution method. So there's nothing hard about this. This is called substitution. Okay? All right. The next method is called the addition method. This is method 2. Method 2 is called the addition method. Okay? Sometimes you'll see it called the elimination method. Sometimes you'll see it called the elimination. Okay, some books will call it the elimination method. So they talk about the elimination method on page 769. So read that section. I'm not going to write that all this out because it's 7 steps. It's a lot of writing. I'm not going to do it. You can read it. Read that section on how to do the elimination method. I'm going to do one. So example 3, they ask us to solve the system by the addition method. Solve the system by the addition method. Okay? Well, so 5x equals 4y plus 6. That's one of the equations. Second equation is negative 3x plus 7y equals 1. So there's my system. 5x equals 4y plus 6. And they have 3x plus 7y equals 1. Okay? Well, the first step is you want the equations in the same form. And typically you want them so that the x and y terms are on one side, numbers only on the other side. So I'm going to take this first equation and I'm going to subtract 4y on both sides. Okay? So that would give me 5x minus 4y equals 6. This equation and this equation are the same thing. It's just in a different form now. So my new system is 5x minus 4y equals 6. And the second equation I didn't do anything to. 3x plus 7y equals 1. These two lines are the same thing as those two lines. They represent the exact same lines. Okay? All right, so now I want to solve this system by what's called the addition method. Well, what the addition method does is you're going to figure out, I'm going to try to eliminate, and again, some people call it the elimination method because what you're going to do is you want to eliminate either the x variable or the y variable. It doesn't matter which. Okay? It doesn't matter which. Now, the way you eliminate them is, If I want them to go away, then they have to be opposites. So right now I've got a 5. So we're gonna eliminate. This is what I choose to do. The x variable. I'm going to eliminate the x variable. That's my plan. Eliminate the x variable. So right now I've got a positive 5x and a negative 3x, and we're going to add the two equations together to do it. That's the other reason it's called the addition method. But again, if I add these two equations together, then this term and this term are going to need to be opposites. So the first thing I'm going to do is I'm going to figure out what I need to multiply both equations by so that the x variable will go away. So I'm going to multiply this equation because I see a 5x and a 3x. The least common multiple is 15x. So I'm going to multiply this equation by 3. If I do it on this side, I do it on the other side. Whatever you do on one side of the equation, do the same for the other. 3 times 5x will make a positive 15x. This one I'm going to multiply by 5. 5 times negative 3x plus 7y. If I do it on that side, I got to do it on this side. Now, what's my new system? What is my new system? Well, when I multiply 3 times 5x, I'll get 15x. 3 times negative 4 makes negative 12y equals 3 times 6 makes 18. The second one, 5 times negative 3 makes negative 15x. 5 times a positive 7 makes plus 35y. And 5 times 1 makes 5. There's my new system. And again, this original system, these two lines, are still exactly the same two lines. They're just in a different form. Whenever I multiply the same thing on both sides or divide the same thing on both sides, those are equivalent equations. They represent the exact same lines. So that system and that system are the same system. Now add the two. 15x minus 15x goes away. We've eliminated the x variable. That's the whole point of the addition method. One variable gets eliminated. That's why some people call it the elimination method. Add the y coordinates. Negative 12y plus 35y is 23y. Add, so equal sign comes down. 18 plus 5 is 23. 23y equals 23. Divide both sides by 23. Y is 1. Once you get one of the two variables, you can use either one of these two equations to find the other. So I'm going to use this one. 5x equals 4y plus 6. I could use either one of these two equations to find the x coordinate. Any one of the two equations in either form you see it in. Okay? So I know what y is. Y is 1. So 4 times 1 makes 4 plus 6. So 5x equals 10. Divided by 5x equals 2. So my solution is 2 comma 1. My solution to this system is 2 comma 1. Okay? That's the addition method. If you check that 2 comma 1 in both of these equations, it will be the solution. Or in both of those equations, it will be the solution. And again, I told you, these are lines. If you graph both of these lines, they would cross at the point 2 comma 1. This is a consistent system with one unique solution. These two lines cross at the point 2 comma 1. Okay. So that's how we do the addition method and how we do the elimination method. Okay. I'm going to pause for just a second. Okay. So that again is the addition method. Okay. Example 4. Let's do another one. Example 4. Example 4, they ask us to solve by addition method. And they give us negative 2/5 x. So this one has fractions. Minus y equals 19 over 10. And the second equation they give us is 5 times x plus y equals negative 7y minus 41. So they gave us two pretty ugly lines. They gave us two pretty ugly lines, okay? Well, the first thing is to clean them up, get rid of the fractions, get rid of the parentheses, write them in the form ax plus by equals c. We want them all in that form, okay? So to get rid of fractions, I'm going to multiply this thing by 10. Multiply by 10, okay? So if I multiply everything by 10, 10 times 2, 10 times 2 fifths x minus 10 times y. Every term on both sides, 10 times 19 over 10. Okay? Well, 5 goes into 10 twice. 10 over 5 is 2. 2 times 2 makes 4x minus 10y equals 10 cancels 19. So this line is the same as that line. 4x minus 10y equals 19. That's what I said. Two lines can be the exact same line but look completely different. 2 fifths x minus y equals 19 tenths and 4x minus 10y equals 19 are the exact same line. But they look like they're completely different lines. That's why somebody can give you a system and you won't know it initially, but it's the same line. They can look very different. Now, this second thing, let's take this dude. Let's multiply through. 5 times x is 5x. 5 times y is plus 5y. And then over here equals negative 7y minus 41. Let's get all the terms with x and y on one side, numbers only on the other. So I'm going to add 7y to both sides. Do it on one side, I got to do it on the other side. 5x plus 12y equals negative 41. So now our system looks a lot better. Let's write down the system of two lines. They're going to look a lot better than they did initially. So that first line turned into 4x minus 10y equals 19. This line, when I cleaned him up, became 5x plus 12y equals negative 41. There's the system. That system and this system are the exact same two lines. That system and this system are the exact same two lines, okay? But again, that's a much cleaner looking system, okay? It's a much cleaner looking system. So now I want to solve this by the addition method, and I want to get rid of one of the two variables. It never matters whether you get rid of the x variable or the y variable. Does not matter, okay? They got rid of, in your book, they eliminated the x variable. I'm going to eliminate y. Doesn't matter. I'm going to eliminate the y variable. That's what I choose to do. So I've got a negative 10 and a 12, okay? The least common multiple with a negative 10 and a 12 is going to be 120, okay? Is that right? Yes, 120. So I'm going to multiply this thing, multiply by 10, 12. And I'm going to multiply him every term by 10. So multiply every term by 12. 12 times 4 gives me 48x. 12 times this one gives me negative 120y equals 12 times 19, I don't know. It's 18, 3, 0, 9, 1, 8, 2, 228. 228. Okay? Multiply everything here by 10. 5 times 10 gives me 50x. 12 times 10 gives me plus 120y equals 10 times negative that is negative 410. Now I'm going to add them. Because now when I add them, the y term goes away. 48x and 50x, when I add those two together, gives me 98x. These cancel each other. 410 are 228 minus 410. And again, the book did it the other way, so this way you'll have you'll see two solutions. So 228 minus 410. I get 182, negative 182. Divide by 98. Okay? Divide by 98. Is it going to be a fraction? Yeah, it's gonna be a fraction, so it's pretty nasty. So it would have been kind of ugly either way. Okay? So one way to handle these fractions, 98 does not go into 182, but just find the common divisor. Find the common divisor. And you can start with 2's. 182 divided by 2 is 91. 98 divided by 2 is 49. Okay? Okay? And then you got to ask yourself, is that reduced? I know 7 goes into 49. Does 7 go into 91? I think it does, 13. So 91 divided by 7 is negative 13. 49 divided by 7 is 7. So x is negative 13 over 7. And I think, yeah, that's the same thing they got. Once you find x, now we can put it in either one of these equations. These, this, doesn't matter. And I can find y. Well, I don't care. Let's put it in this. He's not too bad. 2/5 times x. X is negative 13/7 minus y equals 19 over 10. Okay? Well, 2 times negative 13 is negative 26. 5 times 7 is 35 minus y equals 19 over 10. All I did was 2 times negative 13 is negative 26. 5 times 7 is 35 minus the y equals 19 over 10. And now I got to solve for y. Okay, now I got to solve for y. Well, let's add 26 over 35 to both sides. And I'll have negative y equals 19 over 10 plus 26 over 35. And multiply both sides by a negative. That'll make him negative, but that'll make the whole thing negative. Okay? Y should be, yeah, y is going to try to be negative. So really you're just taking negative 19 over 10 minus 26 over 35. Okay? So 35, 70 is the LCD. 70. 10 goes into 77 times. 7 times 19. And I know this is kind of hairy, but, and you can take your calculator. This is TI 36. Take your calculator and do these two fractions. Let's just do that. So 19 over 10 and 26, 35. I get 37 over 14. Y turns out to be negative 37 over 14. So my solution, 13 over 7, negative 37 over 14. You can check it. It wouldn't be fun, but you can check it. That is the correct solution. Okay? So some of them get kind of rough, especially when you have these fractions, but use your calculator. Your calculator can handle fractions. Okay? Your calculator can handle fractions. All right? So that's the addition method for one more. We did one more example with the addition method. Example 5. Solve the system. And they say 2x plus y equals 4 and 6x plus 3y equals 6. Now they didn't tell me how to solve it. I can use either the addition method or I can use the substitution method. Let's use substitution. We're going to use substitution. So I'm going to take 2x plus y equals 4. I'm going to solve for y. Okay? So subtract 2x from both sides. Y equals negative 2x plus 4. Now substitute that into the other equation. So now, substitute. So 6x plus 3 times y, but we know what y is now. It's negative 2x plus 4 equals 6. Okay? I substituted in place of y. I put this stuff. So I get 6x, let's distribute. 3 times negative 2 makes minus 6x. 3 times 4 makes plus 12 equals 6. 6x minus 6x cancels each other. And we have 12 equals 6. That is a false statement. 12 can't be equal to 6. So we tried our normal solving. I went into the same type problem if I had done the addition method. It doesn't matter which method you choose. But when I went through my method, I wound up with a false statement. Remember we said there are 3 possibilities for 2 lines in the plane. They can cross at a unique point and we get a unique solution like we did here. They can be parallel and never cross, right? If you get this and you get a false statement, that means there's no solution. The lines were parallel. It turns out that those lines were parallel to each other. Okay? Now I've already put this one in slope-intercept form, right? Y equals mx plus b. When I solve for y, I actually put it in slope-intercept form. So y equals negative 2x plus 4. My slope was negative 2. My y-intercept was 4. Let's look at the other line. 6x plus 3y equals 6. Let's solve for y. So subtract 6x. So 3y equals negative 6x plus 6 divided by 3. Do it everywhere. Y is negative 2x plus 2. Y equals mx plus b, so my slope is still negative 2. My y-intercept, though, is now positive 2. So this first line right here had a slope of negative 2, y-intercept 4. This second line right here had a slope 2, y-intercept negative 2. So it has the same slope but different y-intercepts. That's exactly what parallel means. So those 2 lines never intersect, and hence there's no solution to the system. So don't forget that. And the way you'll know is when you go through your solving process, if you get a false statement, the variables go away, but you get a false statement, that means there's no solution. That's your hint, that there's no solution to the system. Okay? Example 6. Solve. This time they say y equals 2x minus 1. Okay? And they say that 8x minus 4y equals 4. There's my system. Okay? Y equals 2x minus 1. And 8x minus 4y equals 4. Okay? Well, this one is set up to use substitution because one of the equations is already solved for y. So I'm just going to go ahead and substitute. I'm going to use substitution. In place of y in this second equation, where I have that y, I'm going to put 2x minus 1. So 8x minus 4 times y, but again, y is 2x minus 1. That equals 4. This problem is set up to perform substitution. All right, let's do a distributive property. 8x, negative 4 times 2 makes minus 8x. Negative 4 times negative 1 makes plus 4 equals 4. 8x minus 8x goes away. This time the variables went away, but I got a true statement. That one the variables went away and I got a false statement. There's no solution. This one the variables go away and I get a true statement. There are an infinite number of solutions. Infinite number of solutions. Okay? Every point on that line is on that line because they're the same line. These two things are the same line. Let's make sure we understand that. Take 8x minus 4y equals 4, and we're going to solve for y. We're going to put them in the same form. I'm going to solve this equation for y. So subtract 8x from both sides. That gives me negative 4y equals negative 8x plus 4. Divide everything by negative 4. Divide there, you got to divide everywhere by negative 4. Y equals 2x minus 1. That's the exact same line. It turns out they were the same line. We just didn't know it. Okay? That's what I mean. Lines can be the same line, but they don't look like it at all. And the solution set, again, any point on this line is on that line. Okay? Infinite number of solutions. So if you wanted to write it, you could say the solution set all the points x comma 2x minus 1. You give me an x, like x is 1. Plug it in there. 2 times 1 is 2 minus 1 or 1, when y would be 1. So x comma y is 2x minus 1. So that's your solution set. All right. That is our last example. We are finished with 8.1. Let me know if you have any issues.